Good evening, good day, hello all. So today I'm Anirban. Like to experiment and show how we can work with a SRS document, the software requirement specification document. We have learnt about this from the time we entered the IT industry. I'm sure all of us. I learnt about the IEEE SRS specification right back in 1994 when I did my training, initial training in IT organization on my first IT job. So today I'm trying to see how we can process this SRS document and extract the requirements as user stories using some of the commercial LLM, and then use these user stories as an input to generate meaningful cases and testing scenarios using agentic approach. So agentic approach I am using Langgraph and openAI, and for extracting the user stories from the document I am using the Gemini 5 Pro. So in this example I use multiple commercial LLMs, a combination of agentic approach to finally get to my user stories testing scenarios. To start with, my open source SRS document is this one, and I'll give the link to this in the description box. So this is a SRS document which I think the table of content doesn't work very well. So we'll go to the start of this. This is as we can see, a NATO unclassified system requirement specification document. The pretty good document we use sometimes in our POCs, and in some customers when we don't have access to a proper requirement document, we can work with this as an initial document and show some results. So it's open source document. I'm taking this. So this basically describes a tool to be delivered under the IKM tools project. It describes a non-functional requirement, design constraints, and other factors. It gives the scope of this particular tool and acronyms and references, right? And then as we can see, as we go in this document, it has nice diagrams which shows the overall architecture of the system, the workflow aspects of the system, the presentation services, the backend layer, all that, and users and roles, describes all these things. And then in section 3 onwards, it basically starts describing the requirements, what this tool is about. So it gives the deployment diagram, all that. Document, open source, good for experimentation. So from 3 onwards, it gives the functional requirement. So as we can see, each requirement has a requirement header like integration, and then it has a set of requirement IDs like IKM SRS 5. This tool shall leverage the services, these services being Microsoft Skype or Teams or it is, and it lists the requirements under this requirement header. That's the overall structure of this document. That's what I have seen. So gives the various requirement headers, like we can see presentation services here. So I have taken up one such requirement header as an input. So I'm giving as an input a requirement header, let's say the search, and I want to find out all the requirement IDs under that and convert them to user stories. And then from these user stories, I want to basically generate the testing scenarios. Now the requirement which I will get from this requirement header should not be only the requirements listed under this, it should also consider the interrelated requirements, right? So that is important. So we can see all these requirement IDs and we can go and validate whether these have been converted into user stories. So that is what my first task. So as we can see, we give the file name here. We basically use Google Generative AI package and PyPDF loader from LangChain community. So all I do is I use a Google Gemini 1.5 Pro because I can use the context length over here very effectively. So I just collect the text from this PDF and in a text field. That's what I'm doing here, actually iterating through the pages of the PDF and then collecting the text. And then I have my prompt, so I give a persona saying you are an expert requirement analyst who can find out relevant requirements from the requirement header given, right, using the text from the context included below. The context basically is the entire software requirement specification document. Requirement header is the requirement for which I want the user story. So in this case, I'll just specify search. So it should be all the search related user stories from this document. User stories already available. Now this particular aspect is there because we can find as we work on the Google Gemini 1.5 Pro, although it has a 2 million context length as an input, the output length is restricted to 8192. This is what I was not aware of. As I was reading, I found out that the output length is actually 8192 tokens, and this link actually will show us that this is what it is. I can open this link also in a window and find that out. So for example, if I go here, we can see that Gemini 1.5 Pro, the max output tokens is 8192. This is where I was running into a limitation because if there are many requirements for this requirement topic, then output user stories out with the description and acceptance criteria. If there are, let's say, 10 or 15 such user stories, it might set 8192 token length. So it was getting truncated. So instead of 10, it was giving only 3 user stories. So the only way I could think of making it work is putting it in a loop, and when it's got the user stories, let's say it has got the first 3, I put it as already available user stories over here, and I asked the LLM engine to ignore this and get the new user stories. So that is where this already available user stories are coming in. So at every loop invocation, I get the user stories, I feed it back in so that I get the next user stories, and I don't feed the 8192 token length, max token output token length, and still get all the user stories. After that, it's pretty simple. Configure the generative AI. So all we need is a Google API key, which I have already set up here, my own Google API key, and we say model as the generative model from Gemini library, Gemini 1.5 Pro, and my context is the text which I collected from this PDF. So this is the text which I am getting from this PDF. So that is my context. I set the temperature on the top P, and I create the prompt by giving the inputs, which is the requirement, which is the header, search, just one word search, the context, which is the entire PDF, the SRS document contents, and the story is available, which is initially there is nothing, so it's blank. So then I get the response by using the model.generate content with the generation config that I'm using, and once I get the response, I can get the user stories out of it, and I append these user stories to the user stories list, and that becomes my user available for the next invocation. So I go from 1 to 4 over here, I equal to 1 to 4. So I store the final output in a file, could be us5.txt, whatever it is. I'll change it us6.txt so not to overwrite what I got earlier. So when I run this, extract us.py, so it basically starts running, and we can see the output here as we go, the user stories that are being extracted. I run it partially and stop it. Don't want to waste my tokens or the cost. So let's see how this works. So it's first trying to read the PDF and extract the page content from it. So it has got 281 pages from here, from the PDF. So that's the number of pages, and this is the first iteration. This is the I which is being printed here. As I said, instead of invoking it once, I'm invoking it multiple times by feeding back the user stories that I am getting, so that I don't exceed the 8192 context length. which is a restriction on the output, right? So I'll just do one iteration now and then stop it, because I've already collected my output. So it's now basically doing this model.generate content from the entire context, which is the SRS document, and it's trying to get the users under the requirement search. So it has got these. So let's say IKM SRS 39B. As an IKM tools user, I want the search service to handle a large amount of data and provide fast, reliable search results. IKM 39B search service indexes and searches at least 18 million items in ON and 7 million items in PBN without errors. Like this, it keeps on 39, 39B. These are the requirement IDs, right? It has got some requirements from other parts of the documents which it thinks are related to the search service. So, and it keeps on going. So this is what it happens, and it keeps on going. So 39B, for example, if we go here, 39B, we can look up the requirement. Yes, 39B, the IKM tool search service will be capable at least. So this has got it correctly, right? And we can stop this process now. Here. You can see it's getting the user stories. So, and we can finally write it into a file. So my last output is here. We can see the user stories here in a nice JSON format, the user story and the mapped requirement ID. That's one part of my prompt, that when I get a user story, it should be mapped to the requirement ID in the SRS document. So it's giving me that very nicely. The description of the user story, and I'm very particular about the acceptance criteria, because this acceptance criteria will drive my test cases, right? So I need the acceptance criteria very neatly. So these are the various things. So we can pick up any one user story now to generate my testing scenarios. So for example, we can take IKM 45 for example to so I'll take this output now and now put it into my Agentic AI project, so that I can generate the test cases from these user stories. So what is my Agentic AI project? So basically I am using the Langgraph here, right? So when I use a Langgraph, basically the way it goes is we define this with memory, the agent state, right? But the most, and the model, which model we are going to use here, I'm using the GPT 3.5 Turbo. So, right, so chat openAI is basically being used over here from LangChain, right? And from LangChain openAI, import chat openAI. So that's what I'm using. Now here, how it works is we have a plan prompt. The plan prompt says in short what is the task to be done. So here we just say the persona, and we say that write the test cases following the SMART paradigm, utilize the information below where I give the input as a story, the description and the acceptance criteria, which is what I have already extracted, right? Any one of them. And then important thing about agentic workflow, what I found from the tutorials in deeplearning.ai is that it is a iterative loop where one generates the output, one critiques it, and again regenerate it. That's the advantage. See, in a non-prompt engineering, what we do is send a prompt, very nicely written prompt, and we get the output. But agentic AI, what happens is we go one step further. We critique the output using a critique node, and then we again regenerate the output. This can go on for of iterations what we specify. It can 3-4 iterations. Of course, it might cost more, but generally agentic output is better than single prompt engineering output. That's what has been found. I'm trying to use that in my scenario. So for example, I'm now using it for my I'm now using it for my agentic AI approach. So that the prompt is this. The writer prompt is where I have the detailed prompt where we are giving, just like in the other case, that the persona, the quality assurance person who is tasked with writing test cases from user stories, generate test cases from the acceptance criteria and from the description of the user story. Each test case should have test steps, expected results. It's all the details that I can think of. I say the generate positive and negative test cases, give the output in a JSON format, right? Generate at least 10 test cases, and I give this user story, description, and acceptance criteria. Now here's the important part. Here we say there is a reflection prompt. So we say you are a domain expert evaluating the test cases, generate critique and recommendations for the test cases, provide detailed recommendations including positive scenarios and non-functional test cases. So now when I do this, I basically create these nodes, the plan node, the generation node, and the reflection node, and then I create a state graph. I initialize a state graph in state, and I add these nodes, the node, the generate node, and the reflect, right? And I set up connections between them. So generate, it should continue. If the should continue is true, it will continue to the reflect, and otherwise it might end also if it meets the criteria. But then from the planner we connect to the generate node, and from the reflect also we connect to the generate node. So from generate, from planner is the entry point, it goes to generate, from generate it goes to reflect, and from reflect again it goes to generate. And then we just compile. We can see typically also I didn't plot the things, okay, so but this is how we can add the edges and add the nodes. That's very simple as that, and each node is made up of these prompts we just now showed. Very simple. So now I get the user story from the file using the get user story and passing the requirement ID. So I just thought of using the requirement ID, one of the requirement IDs, which is we can try with any requirement ID as such. So I am trying one requirement ID, which is IKM SRS 48, right? So that is what it is, and once we do this, we basically then do start the graph execution, right, with the nodes, and we can give the max revisions number. The more the revisions, the more the times it will iterate, and this is the final output. What will get number of revision number is 1, which is the final output will get, which could be the third revision or the fourth revision, whatever we specify as the max revisions, and we can give an entry point task saying simply generate test cases for the given user story. Collect the output and write to a file. Right. I'll change the name to 7 so that I can show the other file that I have, which I have already generated. So now here I need the openAI API key, obviously. So I just run this code, Python agentic tcgen.py. So what it does is it reads the information. What we want to see here is how it generates the critique of the test cases. So its planner is now going through this test case through this user story, and it is generating the test cases, and then we will find that the critique is coming, and it is critiquing that. So here reflect critique, test case evaluation and recommendation. User can enter search queries in natural language. Recommendation, add a verification step to confirm that the search results match the system effectively interprets natural language queries. So recommendation, the test case verifies the system ability to interpret natural language queries. So it is generating recommendations, and those recommendations are back, and it is again generating. So the generate node has gone to, and it has again generated number of test cases. So again it has generated, it has critiqued it. Test user can enter search queries in a positive way, clear and concise test steps, ensures users can input search queries in natural language. Recommendations include a test step where an incorrect language query is entered to check error handling. So all these recommendations are being generated automatically, which you would otherwise do by validating those test cases, and the final result is coming here in the generate node after this 3 iterations. And we can read this we see that this is basically the revision number 4, and we can read this. So I have a simple code that if the revision number is 4, then we show the test cases which are generated. So I'll just take this file which is already there. So if you see, so these are the test cases which are in the JSON format which has been generated. So we can see a test case 1, user can search queries in a natural language to verify that the IKM tools allow users to input search queries in natural language, etc. System effectively interprets natural language queries. Search is aggregated from these two systems using multiple search services. Search results are presented to the user in a proper way. Invalid search query format. So this is a negative test case. So it is saying test case type as negative. So that give the test case type, is it a positive or a negative? Sometimes customers want to see that, to see a good balance of positive and negative test cases. So I gave that a part of the prompt, and it is given test steps, preconditions, all those things, objective, it's part of the test case, and it's a test case IDs also. So I can see these test cases, and if I think that it's not enough, I can again generate by adding one more iteration to this loop, right? That is the advantage of the agentic approach. Yes, cost wise it might be empty search input, all those things. Cost wise it might be little more, but that is the agentic approach which I found is useful and need better accuracies in most scenarios. So we can try another such use case if you want. I was trying this particular user story, and I thought I'll use one of the use cases from here. So we can take up the sort and search results maybe. So if this we can take up, so we can use this user story as an input, and we can also try to generate it, right? So I haven't tested the output format of this file. So what I can do is the file that I'm having, I can add this user story requirement ID and then see whether I can read this. This is a little different format, so there is a blank here. So some of the improvements we can give the output JSON format as a hint to the LLM so that it can get these things. Yeah, so I just put it in the same format which I have generated already, and now I can give IKM SRS 45 to my program to get the requirement ID, which is instead of 48 I can give 45. This is the input in the plan node and in this node. 45 I have output it, and in order not to override the previous output, I will make it a different file name in the output. So I can run it. Okay, line 78. So I want to sort the search results so I can view them in a meaningful order. Pretty much got, so it is generating the test cases, the plan node, and then it has gone to the generate node. From the generate node, now it will go to the, so it will generate the first set of test cases, and then it is going to the critic node. So the critic reflection node, so it is critiquing, verify sorting functionality based on date criteria, etc. Ensure to include verification. So before I did, add a non-functional test case to measure system resources consumed during sorting. See how nicely it is these recommendations and all these things. Include test cases where sorting is without search results available. Right? Tell the sorting of the large data set to assess performance scalability. So it is critiquing, and it's generating the test cases multiple times. So the final is what we get as revision number 4, and we can read it and see how it looks. So we can see that it generated 10 test cases, So it has for this particular user story. User can enter search queries in natural language, right? Okay, so I am not reading this particular this thing. I'm looking at the previous one only. So read test case. I think I generated in Langgraph. What was the file name I gave? Output file name. I would have given 8. So these are the various test cases I've generated for this sorting user story. Verify sorting functionally based on date criteria, the description, preconditions, expected result, right? All those things. Sorting will be based on relevance criteria, verify sorting will be based on author criteria, and based on title criteria, etc. Verify overall efficiency, performance, verify sorting valid criteria, etc. So it is generating these test cases, and we can see it in a nice JSON format. There are more improvements that can be done. For example, we can output into a pydantic data model instead of a JSON format, because I've seen JSON formats are not consistent, so a pydantic data model is better, right? We can do all the improvements, but otherwise this is the basic idea I wanted to show, how we can use combination of LLMs to extract user stories from SRS document and then generate test cases with iterative agentic approach. This is something we see a lot of requirement from different customers to generate test cases, even code which is testing scripts, and there is a lot of SME validation going. It's not like we generate once and then we are fine with it. There are multiple iterations to increase the accuracy of cases, increase the accuracy of the negative scenarios, positive scenarios, to see whether they are actually compatible with the user story input, and all those validations happening, and we have multiple rounds of accuracy improvement using the prompt engineering and all. But using agentic approach, we can automate all that to some extent, in my view, and it might increase the accuracy at the first go, and we can keep changing the number of iterations to have more accuracy or better results, and keep inputting our inputs into the prompt to make it better, into the intermediate critic prompt. The critic prompt is very simple, that we are saying as a domain expert, this is the thing, you are, please critique the output and generate better test cases. But we can introduce better critics based on the feedback from the users and generate even better test cases. With that, I'll end it. Thank you. Thank you all.